Hi everyone, welcome into the stream. I hope you all are doing well. Oh god, it's been a week since I last streamed. Oh, what? Why is it not capturing? Why is it not capturing? There we go. Oh my god. Okay, hi everyone, welcome in. I hope you're having a good day. Oh my god. Yeah, I'm busy. I've been busy. Lots of work to get on with, but hey, I have time to stream. Mainly because I'm bored, for once. I don't want to do any work tonight. I've been doing a lot of work. So, you know what? I'm gonna do something fun. And by something fun, I mean maths. Because maths is fun. I'm gonna watch my view count drop now after I say that. Anyways. Yeah, hi everyone. I hope you're doing well. We're just gonna be doing a tmua today. Specifically, tmua paper 2 from 2021. For those of you who don't know, the tmua is a university admissions test, and I'm taking it soon. So yeah. Also, for anyone interested and in like potential revision or stuff, I'm also going to be doing a similar stream, probably again closer to the exam date, as well as more math streams for Pure Mathematics 4 and Mechanics 2. For A-level maths at Excel, but not Stats 2 because Stats 2 is for bums and is way too easy. No, seriously, it's Stats 2. Stats 2, you just like, oh wow, Poisson distribution. Time to put numbers into a formula again. Wow, I love doing formula work. Am I right, guys? Like, oh my god, Stats 2 is the most buns module. Why is my thing disappeared? It is so boring. It is such a boring module. You just do Poisson, binomial. Oh, let's do an approximation question for once. And then, like, once in a while, you're gonna get a fun integration question with the, PDF, with the probability distribution functions. It is such a boring module. Sorry, I went on a bit of a tangent there. Hi WD, welcome in. Am I right, lads, or am I right, lads? So true. God. I'd watch that series if it didn't have 5 billion slurs. Again. I've watched it before. Anyways, let's get to work. Find the value of the integration of that. Right. How do I use PDF gear again? Ink, right? It's this button? Yeah, this is the one. Okay, so again, we already have this, so we're actually going to simplify it into something, into an easier form, being 3 root x plus... This is one of the easier questions on this paper, especially given that it's not actually any problem solving and it's just pure algebra. So that's a good thing. 3 over 2, so that's going to be 2x to the power of 3 over 2. That's going to be minus 4. Yeah, this is a pure integration question, if I'm gonna be completely honest. Like, this is, what? I'd say P2 level stuff, honestly. Hi Sam, welcome in. Yeah, this is honestly P2 level stuff. 4 to the power of 3 root 2 is gonna be 8. Minus 4 over 4, minus 2 times 1, plus 4 over 1. That's gonna be minus 1, minus 3, minus 3 plus 1, 16 plus 1, 17. Imagine if I get that wrong. Imagine if I get that wrong. It's gonna be so embarrassing. I'm actually redoing my math now, just to make sure I don't get that wrong. 4 to the power of 3 over 2, that's gonna be 4 times root 4, which is gonna be 8, obviously. And that's gonna be, so that's 16 minus 4, yes, 12. 12 minus 2 times 1 to the power of 3 over 2. 12 minus 2, 10 plus 4. Hang on a second. No, hang on. 16 minus 1, 15, minus 2, 13, plus 4, 17. Okay, I need to stop double guessing myself. I need to trust my gut. I need to trust my gut more. A, C are opposite vertices of the square ABCD. Okay, so you are 0, 2, 0, 2, and 4, 0. The equation through A, B, and D. Okay, so it's the square. So the square, the diagonals perpendicularly bisect. So this point is gonna be 2, 1. Yeah, 2, 1. What kind of square is this? This is 4, 2. Then this is gonna be 0, 0. This isn't a bloody square! Hang on a second! A, B, C, D. So yeah, they're opposite vertices. 0, 2, 4, 0. Unless the square looks different than this. Right? Because that's also a possibility. Yeah, no, this has to be a trick question, right? So 4, 0. We know that the two diagonals of a square perpendicularly bisect each other. So that's gonna be here at 1 and 2. So this is a gradient of -1/2. So the gradient of the other one must be 2. So m equals 2. Y minus 2 is equal to 2 of x minus 1. So that's going to be y equals 2x, which isn't a solution. Awkward. That's really awkward. What is going on with this question? Oh, it's because this is wrong. This is wrong. That's 2, 1. That's 2, 1. I'm actually stupid. That's 2, 1. This is going to be 2x minus 4, y equals y minus 1, so that's going to be minus 3. What a weird question. What a weird question. It's probably because the square looks something more like... I don't know. Because that line is going to look something like that. So, like, it probably looks like this or something. It's just rotated. It's a rotated square. And yeah, it's a trick question meant to think that, like, this is, like, it's a regular square, but when it's not. Anyways, student chosen at random from math class, a student is equally likely to be chosen. What is the following conditions is necessary for the probability that the student wears glasses equal to 4/5? Okay. Sorry, 4/15. So... This, okay, so I'm actually gonna explain my working this time, chat. So, basically, the keyword here is necessary. So that means that if this condition is true, then the other condition must also be true, as in A implies B. And... Wait, hang on, no, it's B implies A, isn't it? B implies A? Yeah, B implies A, because B being the probability being equal to 4/5, A being the condition that we're setting here. That's because if it's necessary, then there cannot be any other reason for A being true. I mean, sorry, for B being true, except for A, which means that B implies A. So, specifically in the case of 3 here, as you can see, the class contains 30 students and 8 of them wear glasses. Now, since each student is equally likely to be chosen, it's just going to be the number of students who wear glasses over the total number of students. So in this case, 8/30, which is 4/15. So while this fulfills the condition, meaning it is sufficient, it is not necessary. For example, if it was 15/4, that would still fulfill our condition. As such, this is sufficient but not necessary, so condition 3 cannot be correct. Exactly 11 students in the class do not wear glasses. Again, this is not necessarily correct, because, again, it can be 8/30. So, in that condition, 22 doesn't wear glasses, so while it is sufficient, it's not even sufficient. There's no set limit for how many students there are. Now, lastly, looking at 3. The number of students in the class must be divisible by 3. 4/15. So this is the simplified version of the number of students wearing glasses over the number of students. Meaning that whatever it is, it's actually 4x over 15x, which you can rewrite as 4x is equal to 3 times 5x. Therefore, the number of students in the class must be divisible by 3. So the answer is C. Alright. What the hell is this? Consider the claim about positive integers a, b, and c. Which of the following provides a counterexample to this claim? Okay. If a is a factor of bc, then a is a factor of b, or a is a factor of c. Alright? So this one we just need to do the math, right? A is 5. Is it BC is 200, right? 5 is a factor of 200. Then A is a factor of B, or A is a factor of C. Yeah, this is correct, which means that this is not a counterexample because again it proves it true. Hi Zebra, welcome in. I swear I explain my working out. I'm trying to make this as easy to follow as possible. So, again... this is going to be a counterexample. So, BC here is 4 times 4, which is 16. Now, A, which is 8, is a factor of 16. So this condition is met, but A is not a factor of B or a factor of C. 8 is not a factor of 4 or 4. Mainly because 8 is greater than 4, so 2 is correct. Now, last one. Okay. So BC here is going to be 72, which A is indeed a factor of, because 72 over 6 is going to give you 12. Is that... Hang on a bloody second. 66, 72. 60, 72. What am I doing? 7 times 12. Hang on. No. It's 84. It's 84. I'm actually stupid. It's 84. Oh my god, that was nearly bad. Oh god, that was nearly bad, which is 14. I was like, hang on a second. 12? 12 isn't a factor. 12 isn't a multiple of 7. Anyways, it's 14, right? And... So, yeah, A is indeed a factor of BC, and A is a factor of C, because 12 over 6 is equal to 2, which then fulfills this condition. Therefore, this cannot be a counterexample, so the answer is going to be C, unless I'm stupid. Alright. What? Oh, okay. So, which of the following? This is correct. Therefore, so move that over there and then root all of them. Yes, this is correct. Hence, 1 plus cos x equals 1 plus that for all values of x. Yeah, that's about right. Thus, squaring this is equal to the square of this. Let me just... Can you square that? Yes. Can you square that? Yes. Substituting x equals pi gives 0 equals 4. Okay, so substituting x equals pi here, this is going to be minus 1. And substituting pi makes this 0. Well, obviously there must be an error, so... 1 plus root 1. It's because of this line. Mainly because here, basically, you need to remember that this is the, bloody, how do you say this again? This is plus or minus. Oh, wait, so, no, the error is actually going to end up being here. Because the root must always be plus or minus. So in this case, this would be minus, because this should actually be minus. And in this case, 1 minus 1 is going to be 0, giving 0 equals 0. So this is technically where the error is. Well, the first error, at least. Alright, consider the two following statements about polynomial f of x. F of x is exactly equals 0 for exactly 3 values of x. So that means that the polynomial has 3 roots. Something like that can look differently. And f dash of x is equal to 0 for 2 real values of x. So that means that the polynomial has 2 turning points. So, is this necessary for Q? 3 roots? Well, no, because a cubic can look like this. It has 1... Wait. Sufficient. No, if we drew a quartic like that, that has 3 solutions for f of x equals 0, but it has, as you can see, it has 3 turning points, so this is not necessarily correct. P is sufficient, but not necessary for Q. Well, it's not sufficient because... is it sufficient? No, it's not. Because, again, here you can see P true, Q not true. So that cannot be the answer. P is necessary and sufficient? No, obviously not. So therefore it's D. Yeah, it's not necessary and it's not sufficient. Alright. A circle has equation that. So at 9 minus 2... Jesus. 9 minus 2, which is here. There's a circle, radius 2 root... Radius 2! So that's gonna look like that. Oh, no, that was a really bad circle. Where it exactly touches here at 9, 0. A square... Oh my god. A square has the vertices at 1, 0. 1, 2. Negative 1... 1, 2, negative 1, 2, and so like that. Okay. A straight line bisects both the area of the circle and the area of the square. What is the x-coordinate of the point where this straight line meets the x-axis? Okay, so, for either of these conditions need to be true, as the line is straight, the line must pass through the center of the circle and the center of the square, otherwise it cannot bisect. Wait, bisect? That means cut in half, right? Yeah, that means cut in half. So if it's a straight line, these two shapes cannot be cut in half without passing through the center. So we now know that the straight line must pass through 0, 1, and 9, negative 2. Which means that this straight line has a gradient of negative 1 over 3. Rise over run. So it's going to be 3. Yeah, 3 zeros. Yeah. Question 8. Consider the following statement about polynomial px where a and b are real numbers with a less than b. Okay. Hang on, let me have some water. So, there is a number in between a and b. such that it is a turning point. So basically, if A and B were here, there must be a turning point between them. So, the condition PA equals PB is necessary and sufficient. Is there a polynomial where... Oh, congrats on first, Agni! Somehow, even though you're not first. Let me move you up. Yeah, your first chat? Okay. I'll believe it. Okay, so this is actually... Okay. So, necessary and sufficient. PA equals PB. So basically, you can just try and solve this one by elimination. Just by trying to find a counterexample, which is normally how I do these questions. I find this to be the easiest way. Because the instant you provide counterexample, the condition is shattered. Usually. Such that. Is it possible for that to be true? PA equals PB. A polynomial. Yeah, it cannot be a straight line. I mean, hang on, isn't that a polynomial? I mean, no, that's not a fulfilling condition either way. I'm stupid. You know what? I think it's sufficient. Because... Yeah, I think it's sufficient. Is it necessary? No. It's not necessary. I think it's sufficient, not necessary. Because basically, let's say, like... Here. A can be here, B can be here. There's still a turning point for here. So this is true, but PA equals PB is not true. However, it is probably sufficient. Big probably. Yeah, because I'm just thinking, like, there must be a turning point if it reaches the same again in a polynomial. Point of inflection? I mean, point of inflection is technically a turning point anyway, so... Yeah, no, I think it's... Alright, bye, Agni. I think it's sufficient, not necessary. Okay, we'll see, we'll mark it later. Considering the following arguments about a polynomial f of x. Oh, boy. Which of these is sufficient for f of x equals... So we need it to have a root. So, f of x is a cubic where p is not equal to 0. Yes, that's just immediately true. Cubics must pass through the x-axis at least once. There's a real number, t, for which f dash of t equals 0. So that means that there must have a turning point, which is not sufficient, for example. So, no, you're not sufficient. There are numbers... U and V for which this is less than 0. Yeah, I think it actually is. Because the only way this is true is if you are multiplying a positive and a negative number. And if a polynomial is in both positive and negative, there must be a root. So I think it's 1 and 3. 1 and 3C. Alright. The first 7 terms of a sequence of positive integers are that. Considering the following statement about this sequence. If n is a prime number, then u of n is a multiple of 3, or u of n is a multiple of 5, which is the smallest value of n that provides a counterexample. So, if n is a prime number... So we can immediately eliminate all the answers that are not prime numbers, because, well... you know, that can't be a counterexample if it's not like prime. So we need it to be a multiple, not a multiple of 3 or 5. So not you, not you, not you, you. But you're not prime, so you. Right? 3, 5, nope. Okay, it's 5. Next question. Alright. A student tries to solve the following problem, where A and B are non-zero real numbers. Show that if, then... Okay. So, basically, this is a rearrangement question. Probably. Hang on. If that is true, then the A is equal to B multiplied by X plus Y. Is basically, okay. So. Sure. 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 No, wait, hang on. Sure. What happens here? Right. So, all sides are multiplied by x squared, y squared. Sure. Because x squared, y squared... Oh. Hi, Ark. This is the most Asian stream. What the hell? Alright. Because, remember, x squared, y squared must always be positive, given that this is two positive numbers multiplied by each other. So doing this in an inequality is valid, because if it was negative, you would have to consider a flip. But because this must be positive, then that's fine. What is this? So, therefore, okay, so it's basically a equals xy, x plus y, so that's minus 4x cubed, y cubed is greater than 0. So basically this is substitution. Yes. If, then. I don't believe there's an error. Loki forgot how you look because I keep drawing you mugging on accident? What does that mean? Okay. What the hell does this prove? Alright, so this is a true statement no matter what. I think it's true? I'm between one of these, because I don't think it's proved the... Has it proven the converse? Hang on, if I did this in reverse... Right? That doesn't prove anything, so it can't be you. So basically you're trying to say if this, then this... So this implies... No, A implies B. This is A implies B. Right? Hold on. Yeah. Yeah, A implies B. Jesus Christ. A implies B. So... The converse would be B implies A. Jesus Christ. Does this prove that B implies A? So true, Teta. I don't think so. You know what? I'll just go with A. I'm trusting my god on this. It's probably not right, but whatever. I'm sorry. I'm never used to answering like this is correct, because it's barely ever correct. So hey, they might be trying to catch us. It's my song. No, you don't get to claim the whole song. No, thank you. Hit me with the fact that pressing you with a ground. Haven't heard this song falling for a freak. Which the following arguments about polynomial f and a are true. If this for all x, then f of t dt is greater than u, so the area under. Yeah, this is true. Yes, Ark. I'm Lunalato. If, then the gradient... No. Actually... Yeah, I have normal ears. The gradient always greater than or equal to.
Why did it sound like that?
I think is the opposite true? No. I know there's Heartless tomorrow, don't worry. I wouldn't forget. If f dash of g is greater than... Hang on, okay. So if the gradient of x is greater than the gradient of g, then f of x must be greater than g. Because... No, I don't think so. Because that leads to a potential case of, like, say this is gx, and this is f of x. This condition is fulfilled, but obviously this condition is not, so I think it's 1 and 2. Let me just have another look over. If you're greater than you for all... Okay. Yeah, I think this has to be true by definition. I mean, I'm pretty sure the only way that this is true in the first place is if their gradients were equal for all x greater than 0. Because, like, with a different... Hang on. Here, this gradient, which is less steep, technically greater than this gradient. Yeah, no, it's not. It can't be 2. It can't be 2. Right, I think it's 1 only then. So, a region R in the xy plane is defined by the following simultaneous equalities. So, y is less than x plus 3. So, let's do this. And y is less than x squared plus 1. Right. So everything under here, right? And then y is less than x plus 3, which is this line. So it's this. No. Y less than 5? No. Let's have a look at this. This is stupid. What does that mean? Right. Right. So. Oh no. Y minus x. Can I just divide that? I low-key want to divide that. Y is less than x squared plus 3 over y minus x. The hair is so complex, I'm sorry. I sent you a face. Yeah, sure. Y minus x. Three over this. So basically, we're just looking at the condition of... Okay, so... Consider x is equal to 0, y is equal to 0.5. Y 0.5 is less than 3 over 0.5, which is true. That's true. Consider x is equal to... Fuck, man. I think it's true. I think it might just be true. Because we need to think about y minus x here. Because we need that to be... If we want this to be false, right? Then actually, x minus plus 1. What if we try to point like there? It's 1, 2. One, two, 1, 2, 1. So that's 1, 2, right? Yeah, 1, 2. 2 less than. No. 2, 1 maybe? 1 less than 4 plus 3 over minus 1. Huh. Is this playlist on shuffle? Because I swear to play... Oh, it's not. That really explains a lot, huh? Hang on, consider 1, 3. Just so we can make this definite. 9 plus 3 over minus 2. Okay, no, that doesn't prove. But, like, this is equal. None of them. 1, 2 is in the range. Wait, it isn't. It low-key isn't. No, it low-key isn't. Okay, never mind. Okay, it might just be 2. How much time have I spent on this question? Too much. Alright, let's just say none and move on. I don't think I have the means to prove that by anything that's not counterexample, which is proven to be really hard. Consider the following simultaneous equations where p is a real number. P to the power of x plus log 2y equals 2, and that. What is the complete range of p if these have a real solution? Okay. So, let's do some quick rearrangement. Log base 2 of y is equal to 2 minus p to the power of x, which is also equal to 1 minus 2 to the power of x. So, one is equal to p to the p multiplied by 2x minus 2x, like that. 1 is equal to 2 p minus 1. So we need you to have a real solution for... There we go. Okay, we need this to have a real solution. Right. So obviously p can't be 1. That's just a given. So you are already eliminated. So the regular graph of 2 to the power of x is going to be something like that, where it passes through 1 at x equals 0. So p can't be negative. Because p greater than 1, because the instant that p is less than 1, this graph is flipped. So p greater than 1. Now then, is there any case where I need to find a case where this is p greater than 1 true. So basically we're looking at p greater than 2 now. So hang on, let me just eliminate some solutions quickly. Not you, not you, not you. Actually, we'll consider you. Not you, not you. So we can prove this by example. So if p equals 3. If p equals 3, then you're gonna be equal to 3. To the power of x plus 1, basically. Which does have a solution for 1, and x equals minus 1, so this is not true. One is equal to 0.5 times 2 to the power of x. Do you have a solution for 1? Obviously you do. Yeah, I think it's just that. A circle has equation that, where that, ba-da-ba. Which of the following is necessary and sufficient for the circle to be a tangent to the y-axis? What? You want the circle to be a tangent to the y-axis. Oh, so basically, yeah, the circle needs to touch the y-axis at its edge. Okay. So let's just solve this. I mean, let's put this into a different form quickly. Wait, did I low-key forget to do my stream announcement tweet? I've been saying low-key too much, honestly. I don't know why. Yes, I did. Oh, that really... Okay. Y plus B. Yeah. Yeah. Over 4 equal to 0. So basically, the radius of this circle is gonna be the root of a squared over 4 plus b squared over 4. So we actually need the center of the circle in terms of the x to be the plus or minus of this. In which case the x is a over 2. So a over 2 needs to be the plus or minus of a squared plus b squared over 4. Oh, there's a bloody C! Minus C! Well, radius can't be negative, so this actually just has to be positive. And we need to remember that the circle is the minus a over 2. So it's going to be this. Minus a over 2 is equal to that, which is the radius of the circle. Okay, good night. Hang on, I need to go reply to Ghostdoc in my DMs. He's complaining about my commission. I can't wait for you guys to see this. Alright, back to what I'm doing. Right. P and Q are real numbers, and the equation that has exactly k distinct real solutions for x. So this is a straight line. And you... Damn. Positive x. So this is basically a... What's the word? Cubic. What the fuck is the... Hang on. My brain is working. It's working. What the... I forgot what the power of 2 polynomial was. How did I forget? Binomial! It's a binomial. Wait, no, it's... What the... What the stupid curve? The stupid curve. The... So, tries a... That's it, I'm searching it up. Oh, it is a binomial. Wait. No, it isn't. Wait. Quadratic! It's quadratic! Fuck! Yeah, it's a quadratic that's reversed in the x-axis for x less than 0. Is equal to a straight line. Where it has exactly k distinct real solutions for x. So... Okay. Sure. So how many possible values for k are there? I don't think it can be 0. Look here. I don't think it can be 0, because this must be a straight line. Non-zero, though. It doesn't say non-zero, so theoretically this is correct, but also this, as it goes to infinity, doesn't have an asymptote at either of the tails. So even that doesn't. So I think it cannot be 1 with 0, surely. So now we're just trying to find if it can have 4 solutions. So the condition for 4 solutions is... Okay, this is stupid. I need you to have 4 solutions. Let's think. Let's think, chat. Let's put our thinking caps on. So, basically, what we can do here, actually, x squared minus px minus q, we're going to consider everything on the right side of this y-axis here, and then we're going to use our, what the hell is the b squared minus 4ac thing called again? I forgot, but we're going to use it. So b squared is negative p squared minus 4a, which is 1, and then c, which is negative q, greater than 0, right? Which ensures that we have 2 solutions for this intersection. So that's going to be p squared plus 4q greater than 0. So now then we move u here. P squared is greater than minus 4q. Okay. I can't square root this because that's negative. So this is always true. Isn't it? Except when p equals 0, q equals 0. I've done something wrong. No, q negative. It's q negative. This is always true. Can it have... So it basically requires a negative q, is what I'm trying to get at. And this would be a positive q for everything on the left. So basically it's not possible. Because one requires the intersect to be below here, and one requires the intersect to be above. Yeah, it's not possible. So it's 1, 2, and 3. Alright. How long have I been spending on this paper? Oh, okay, we're an hour in. Consider the following functions to find for x greater than 1. Which of the following is true for all values of x greater than 1? Sorry. Okay, so this is actually 1 over 2 log base 2 log base 2 x. Because this is rooted. Meanwhile, this is log base 2 1 over 2 log base 2 of x. Oh, that's actually really silly. Okay. I fuck with this question heavy. Okay. So x greater than 1. So that means that whatever's inside of there is gonna be... Yeah, because that can't be negative. So... What? Hang on. No, sorry, Yonk. I need to stop. Sorry, I need to stop you for a second. What is going on? Okay. So we're gonna be thinking about positives and negatives here. Right. Let's consider this first. Can this come out as a negative? Yes, very easily. When this is less than when this is less than 1. Yeah, it is. When it's less than 1, which is very possible. Yeah, that can be negative. When can that be negative? Alright, so let's consider this. Negative at. So this needs to be in between 0 and 1 for this to be negative. I think. 1 over... yes. Yes. So we need this to be less than 1. Wait, log base 2, 0 comes out as 1. Log base 2, 0. No. Log base 2, 1 comes out as 0. So that's going to be, yeah, it's less than 1. So we need you to be less than 1, which is less than 2. So we need you to be less than 2. And for you to be less than 2, x needs to be less than 4. Right? If this was 2, this would be 1 over 2 minus 1. Meanwhile, if this was 4, this would be 2, 1, 1, 2 log base 2, 1, 0. So past that, yeah, okay. So it's negative at x less than 4. Meanwhile, over here, when are you negative? So again, this needs to be less than 1. Right? Less than 1. Less than 1. Log base 2. Because the log graph looks like this, where here's 1. Wait, no. It looks like, fuck. This. Right? Yeah, it looks like this, where this is 1. And asymptote at x equals 0. So we need u to be less than 1. This is less than 1 when this point is 2. So negative is at x is less than 2. For example, if this was 2, 1, log base 2, 1, 0, this comes out as 0. So let's start considering some of these statements. Right. 0 is greater than f of x. So whenever they're positive, then whenever f of x is positive, it's less than g of x. So let's actually think about some of their graphs. This is negative at x equals 4. So that's like that. Well, you are something like this, probably. This is a really rough, really rough approximation, but whatever. So when f of x is greater than 0, which is this one, it's less than g of x, which is true. But when they're less than 0, then f of x is greater. I'd no longer fuck with this question, exam board. You know? We need to consider their intersection points. I don't want to consider their Actually, I can. Actually, wait. Wait. Let her cook. Let her cook. Let her cook. Right. So. Log base 2. 1 over 2. Log base 2 x is equal to 1 over 2 log base 2. Log base 2 of x. Right? And then we take everything to the power of 2. So that's going to be 2 to the power of that. So that's 2 to the power of log. You just become 1 over 2 log base 2 x. Meanwhile, if we take this 1 over 2 to be on the outer, base 2, you become log base 2x to the power of 1 over 2. Right? And then I don't know where I go from here. Fuck. So let's consider the points that they've given us. Let's just throw in 1. I mean, let's just... let's just throw an x equals 4 in there and see what happens. Right? So when x equals 4, this is 2, meaning this is 1. And when u are 4, this is 2, and then this is root 2. So it's not going to be u. When x equals 2, we are going to hit this with the big old trial and error. The old classic. This is going to be 1, which is equal to, well, you are going to be like, give me 2, so that's going to make you 1, which is not true. So I hate it here. Their intersection point is somewhere between 2 and 4. Fuck! You know what? I don't like this question. We're gonna just come back to it. I low-key don't know how we do that one. That's a hard question. Actually, no. Never leave a question blank. Eeny, meeny, miny, mo. Catch a spider by the toe. If you listen, let go. Eeny, meeny, miny, mo. D! So, a student chooses two distinct real numbers with x and y. Okay. Draw a triangle with AB. Okay, so. I'm just going to draw the sine graph quickly. For up to 180. So AB is going to be equal to 1. Right. So. Sine theta is equal to opposite over hypotenuse. Huh. Okay. So that's the angle at these corresponding points. So technically, what could be... Yeah, okay. For one choice of x and y, there's exactly one triangle that the student... This is why I make up marks on the easy questions. Okay, let's actually do this. Some choices are exactly 2, some choices are exactly 3. Hypothetically, if the student were to choose this and root 3 over 2. That would still leave 2 possibilities, because it could be here and can it be there and there? this would be 130, and you would be, bloody hell, 120. 120 and 30 is very possible, as is 60. Wait, but this is 60 and 150, which is not possible in a triangle. So therefore, there's one possibility for that. Therefore, yes, I feel like this is true. This, mm, mm. Oh wait, hang on. Hmm. Okay. I'm okay. I'm sorry I'm not explaining my thinking through as much, but that's also because I don't know how to think through this question at all. So I'm low-key trying to figure it out on the spot, and my train of thought is working better when I try and not talk and I just work it in my head. There's actually two different triangles that these students draw. What? I just need to prove it once with one example. So, hmm. So this means that hmm. I would do like 170. Yeah. So, I've actually realized, um, the x, the x must be on this side, for this to be possible, because yeah, the x must be on this side, and the y can go wherever it wants. Um, but the x must be less than 90. So a must be less than 90. Can't actually be 1, so we actually can't have a right angle triangle. Interesting. I'm wasting time. Okay. So let's start eliminating solutions. So that leaves us with 5. Mm, yeah, I think because with x locked over here and 2 possible solutions for y, that also means that I. But is y even true now, actually? Um. Well, x was like. Mm, x was like. U. I mean, yeah, no, x can be here. It would force y to be on that side. But if y is on this side, then x must be on this side. They must be on different sides, basically. Well, no, they don't necessarily have to be. Yeah, they can have both be on this side, but they cannot both be on the right side of 90 degrees. I'm just gonna go 1 and 2. I'm just gonna send it. I'm running out of time. Right. An angle can take any of these values. For how many of these values is it true that... What the hell is going on? Okay. So, low-key, I think I want to square this. And just... Yeah, I think I'm gonna square this. Would that be removing solutions? I think it might be. Fuck. Hear me out, hear me out, hear me out. Right, so... What we're looking at right now is 1 plus sine theta to the power of 1 over 2 multiplied by 1 minus sine theta to the power of 1 over 2. Am I allowed to make that this? Let's think. Can I? I think I can. Probably. Yeah, root x. Root x multiplied by root y equals root xy. Therefore, this is allowed. And this, when all multiplied together, is going to be 1 minus... Alright, so when you multiply all of this together, that's going to end out to be 1 minus sine squared, which is actually just cos squared. So this is root of cos squared. So sine theta cos theta plus, and this is also going to turn out to be 1 minus cos squared, which is going to turn out to be sine squared, which is going to become, since it's all rooted, 1 plus sine theta cos theta, which is actually just 2 sine theta cos theta, which is sine 2 theta is equal to 0, right? And then, since we're going from 1 to 360, the graph of sine 2 theta looks like this. Since you can take the value of 360, then that is 1, 2, 3, 4. 4. The answer is 4. A sequence of functions is defined by whatever the hell this is. Okay. And then plus 1 is u plus 1 for n of... Oh, fuck me. Okay, let's just try thinking through this. F dash of x, so f, that means that f2 of x is actually equal to the mod of mod x plus x. And then if we just keep on adding on, it's just going to be like more plus x like that, basically. So we need to figure out the area under the curve from negative 1 to 1. So let's just try with 3 first. If we substitute negative 1 into here, this is going to be negative 1, which will turn out to be... fuck me. Turns out to be 1. Plus minus 1, 0. 0, so that's fine. And then this is going to be minus 1. But if I were to add another 1 onto this, this would... minus 1 would become 1, right? And then add another minus 1, which then becomes 0. So, okay, so at minus 1, it is 0. Got it. At minus 1, it is 0. And then at 1, well, it's going to be x plus itself 99 times. So it's going to be 99x, which is just 99. So I think it's 99 over 2. Because I'm just going to assume it's a triangle. I think that's sound. If I sub-zero into that, that's just bloody 0. Hang on a second. Hang on. What does this look like? Because we know that at -1 it looks like this, at 0 it must be there, and at 99 it must be here. So, what the hell is going on with this? That's sub negative 0.5. Oh, for all values here, this is 0. But for all values greater, it is just that over 2. It's just that. It's just that multiplied by 99. Yeah. Yeah. So since this is 199 and it's a triangle, then this is 99 over 2, I believe. Oh, wait, is that the end? Okay. Do I think I have time to go back and check my answers? No, we've been live for 80 minutes now. And including stream starting time, that's gonna be the 75 minutes that we have for this paper. So, yeah. Alright, so chat, I'm gonna take a quick toilet break, and then we're gonna come back and mark this one together. Alright, I will be right back. Where's my BRB screen? Okay, hang on. Chat. Quick alteration. I low-key had a think. Oh, I low-key thought over the toilet break. I think it's actually 90. I think it's actually 90. I'm gonna look so... Sorry, 99. I'm gonna look so stupid if this is wrong now. But I think it's actually 99. So I've changed my mind. So, well, let me get the mark scheme up real quick. I'd like to thank PMT for all of my mark schemes. Right. Let's do this. 17. Okay, thank God. If I got this one wrong, oh dear. This is E. Okay, good. This is C. Good. This is also C. This is B. This is D. This is B. This is C. This is C. This is E. This is C. Okay, we'll come back to this later. This is B. Yes. This is A. This is C. This is B. Okay. Question 16. Where the hell is 16? Oh, wait. Hang on. Oh, wait. 16 is E. Oh, okay. Wait, hang on. 16 is E, and the previous one is B. So... yeah, it's E. 17 is... where is... oh my god. Start by this reading sketch, you calculate obtaining, we see, which is option F. You know what? I'm fine. I completely picked one randomly there. I have no clue what's going on with that one. So, the correct answer is C. Well, I was close. Yeah, I was starting to doubt statement 1, but oh well. It's fine. That was a bad one, low-key. So option F. F? Hang on. To root with that. Oh, okay. Right, I made a very simple mistake here. Basically, what I did was I had sine theta with the root of cos squared theta. But we need to remember that square roots must always be positive because, yeah. So this is actually sine theta mod cos theta plus cos theta mod sine theta. And so I can't actually do this simplification. Yeah, okay. Dang. So let's just do a quick sketch. Hang on. Like that. So we need sine negative while cos positive, or cos negative while sine positive. So that's going to be this range, sine positive while cos negative is cos negative. No, wait, no, that's that range, and then this range, that's going to be 180. Where did the extra 2 come from? It's going to be when they're all 0, isn't it? Yeah, it's gonna be when they're all 0. Which is, yeah, there and there. No, sorry, not there and there. There and there. Yeah, so that's where 182 comes from. Okay, fair enough. This is... Oh my god, I was right the first time. She's a fucking idiot, Your Honor. She's a fucking idiot, Wait. E? E? 1 plus... Huh? Oh. Oh, okay. So basically, yeah, I know now. So basically, what I realized in the toilet was that this actually looks something like this with another triangle on the other side. Now, I immediately jumped to thinking it's like this, but no, I forgot to remember that this limits at 1 because it's positive, negative, positive, negative, positive, negative. So basically, it's the final result would just be a positive number being the last one. So that means that this is actually just 1 over the area of 1, and since it's a triangle, that's 1 over 2, that's 49.5 plus 0.5, which is going to be E at 50. So, that's 1 mark lost, 2 marks lost, 3 marks lost, 4 marks lost, 5 marks lost, 6 marks lost, and that was it, wasn't it? 14! 14 out of 20. Not my worst, but it could be better. Okay, I'm pretty sure the average on tmua is actually like 12. Wait, no, 12 is like the number you want for Cambridge, right? Apparently, something like that. But like, I'm not... I normally average like in the upper, like in the like 75% plus, so 14 isn't the best. It's fine. I can review these mistakes, I think. If we go... Okay, let's start some review, actually. This one I want to review... I don't even know what's going with this. Question 11. Yeah, hang on. tmua AVG score. Oh, I need to search up the, tmua grade boundaries 2021. Raw score conversion. So, this is 14, which is a 6.9. Nice. With a 6.9, I'm above average. Right, hang on. tmua grade 4. Yeah, so you want about 6.5 or higher for Cambridge. So 6.9, I take that. Especially since I'm not even applying for Cambridge. So I'm happy, low-key. It could have been better, but it's fine. Okay, so let's have a look at question 11 then. Let's start by thinking how each step works, right? So line 2 follows... Oh, it does line... Yeah, that's what I thought. Line 5 assumes that A equals, xy multiplied by x plus y. So... yeah. It proves the converse, because it assumes this is true, then proves it is greater than 0. Yeah, that was low-key bad on my part. I should have thought it through more. It's fine. Alright, question 15. I'm actually stumped on this one, how I got this one wrong. Let's think. So, yeah, we need a circle on the tangent to the y-axis, which basically... equation... Okay. Yeah, so the center of the circle is -1 over 2a and -1 over 2b, with that this as the radius. So, it says that we're basically saying a squared plus b squared over 4 minus c is equal to this. Yeah, because I was low-key thinking about accounting for it can be either side. Which, if we square, gets us to a plus b over 4 minus c is equal to -1 over 2a squared, since this is always positive, but we can ignore that since squaring it will also make it always positive, which then becomes -1 over 4 a squared over 4, positive a squared over 4, which means we can actually eliminate that, which means that move that over there, b squared equals 4c. Okay, fine, fair enough. Yeah. Could have been better. This one was fucked. So... I'm gonna read this in my own time, because I don't think I have the energy for it. Alright, question 18. Yeah, no, this is also not it. Not the time. This is not the time. Okay, I think that's all the questions reviewed then. Overall, not a bad paper, not a good paper. Some mistakes to take away, a lot of things to learn from this, I think. So that's good. I need to learn from past papers a lot. Like, it's just about finding where I mess up. Anyways, chat, I hope that might have been useful for you. I'm not sure if it was, but hey. I low-key just hit a Cambridge competitive score, so, that's fine then. This is how I think. This is how the Luna Lotto think. Yeah. Alright then, chat, I hope you all enjoyed the stream. I'm gonna head off now because I got a Heartless recording and I want to go to bed. Good night!